Hey there, STEM Chemistry. This is Miss Ruark. This is Vodcast 9.5, and we're going to be talking about titrations and titration curves. Okay, so just to recap from 9.1, what is a titration? Well, titration is a process or a method that you would follow that neutralizes an acid or neutralizes a base. And you can actually use that titration and the information you get from it to help you determine the concentration of an unknown acid or base. All right, so how does this work? Well, you're going to be doing this in class and you'll spend a couple days on this lab, so let's make sure that we understand all the different parts. All right. Okay, so to do a titration, you're going to have a setup similar to this where you have your ring stand here. Okay, so this is your ring stand. Here is a burette clamp. It's a burette clamp, and it holds your burette, which is this long glass thing. Okay, and that glass thing is where you would put what we call a titrant. Okay, our titrant is a solution of an acid or a base that has a known concentration, and we say that it is a standardized solution. And the reason we say it's standardized is because it's either a standard stock solution, which means that it comes directly from it's the stock that you have that you dilute to make all of your solutions. Typically it's something that would come from the chemical companies. Okay, or we can say it's standardized because what's happened is you made it and you have titrated it several times to know the exact concentration of it. So for it to be standardized, it has an exact concentration that has been tested time and time and time again. Okay, so we would have our titrant with our known concentration in there, and you guys will all have your titrant with your known concentration, or well, you will have your solutions that you've made, and hopefully they will be good, and you'll have an exact concentration for those. Okay, and then here on the burette you have what we call a stopcock. The stopcock is just a it's exactly that. It's a lever, pretty much, and you turn it either way, and when you turn it, it opens up a teeny tiny hole in the stopcock that allows the titrant to come through. And you want to turn it slowly. Okay, turn it slowly. Ooh, turn. It's supposed to say turn there. I don't know, my pen decided it didn't want to work for a second. All right, so we turn it slowly. And it's got a mind of its own. It's possessed. All right. Slowly. There we go. Turn it slowly so that this will drop out. And the reason we want it to drop out is because if you put too much in there too quickly, you could overshoot your endpoint. All right. So what are we trying to do? Inside of this Erlenmeyer flask here, we need, and it's always going to be an Erlenmeyer flask, we would have what we call our analyte. And our analyte is what we are testing. Okay. It's what we're doing analysis on. So our analyte goes in here. And it has to be an Erlenmeyer flask. We want that conical shape because you want to be able to swirl the stuff that's in here so that it stays nice and mixed. That way you don't have inaccurate data. Now, this little flea down here, that's actually a magnet that in some college classes you'll actually have a stir bar and or we call it a flea or a stir bar, and a stir plate, and then you would be able to have it stir as you mix it. However, this is not such a place, and so you will have to just swirl the flask contents by hand, and I'll show you how to do that in class. All right, so how do we know if we've reached our endpoint? Well, we know we've reached our endpoint when we get a color change, and that color change is brought about by the indicators that we use. Okay, so the question is always, well, what indicator do we use? Well, it all depends on what acid and base you're using and what you're titrating with. Okay, so you have several different ones to choose from, and this is just a list of some of them. This doesn't even give you a complete list. There are tons of them. Okay, but these are just some of the ones that you can use. Now, if we were titrating a strong acid and a strong base, we know that both a strong acid and a strong base will come together and neutralize each other. They completely dissociate, and so they would end up making just a water and just a salt. And therefore, we should have around a pH of 7. Okay, and that would be if it's a strong acid and a strong base. Okay, and we're getting to that in just a second, so don't worry if you're not getting this. So we would actually end up having to choose something that has a pH range around there. We don't want it to be, and notice how it has a range here because it shows your acid in one color, it shows your base in the other color, and then some of them have that third color to show the neutrality or the equivalence point. Okay? So we would want to choose something that has an equivalence point or range around where that pH, where that change should happen. And so let's go ahead and jump into that actually. So if we have a strong acid and a strong base together, we know that they're going to reach that equivalence point at a pH of 7 because the acid is going to completely dissociate because it's a strong acid. And that strong base is going to completely dissociate because it's a strong base. So let's say that we had hydrochloric acid and we mixed with that NaOH. Well, both are strong acid, strong base. The HCl breaks apart completely and the NaOH breaks apart completely. And so we end up with water and we end up with our salt, which is NaCl. Okay, and this is going to be a neutral solution because it was a strong acid and a strong base together, okay, with an equivalence point of around a pH of 7. Now, looking at our chart, we know that we would have to choose the most likely one to choose for this would be bromothymol blue. And the reason for that is because it shows that color change at a pH of 7, which is where the equivalence point should be. Okay, and yeah, so a lot of times you'll see some people will actually use the phenolphthalein, and it does work. The problem is that it has that pH range going from 8 to 10, so it's a little bit more on the basic side, but it can work. But we would probably want to go with bromothymol blue instead. Okay, well, what if we had a weak acid with a strong base? Okay, so if we had a weak acid, the pH is not going to be as far down. Remember, this is pH of 0 down here. Ooh, can't see that color. Okay, so pH of 0 down here, and as we go up, it gets higher, right? So our weak acid isn't going to have as low of a pH. It'll start up a little bit higher. And when it reaches its equivalence point, remember equivalence point is where your hydroxide ions are equal to your hydrogen ions or your hydronium ions. That's where they're equal, and that's your equivalence point. Right? If you go too far, then you've reached your end point here. So this would be your end point showing that the color changes happen and it's all going into base now. Or if it was the other way, it would all be going into acid. All right, so what kind of indicator would we use for this? Well, if we had a weak acid mixing with a strong base, we're going to end up with a weak base for our solution. Okay, it's going to be a weak base solution. So we would have to have something that has a color change that happens more in the light basic area. And so the best thing for us to use there would probably be phenolphthalein, maybe even this alizarin yellow if we had it, but phenolphthalein would be the more common one that you would see there. Okay, here we have a strong base with a strong acid. Now we go back to, and we had strong acid with a strong base, equivalence point at a pH of 7. Well, here we have strong base with a strong acid, equivalence point at a pH of 7. Notice the difference is that it starts with a pH higher and ends with a pH lower. That's the only thing that's different. It's flipped, right? Okay, so the best indicator to use with strong acid, strong base, or strong base, strong acid would probably be bromothymol blue because of the pH range from 6 to 7. Okay. And then our last one here is weak base with a strong acid. Okay, the equivalence point is going to be lower than 7, and the reason for that is because we have a weak base starting with a strong acid, and we put that strong acid in, we're going to end up with a lower pH, which means that our solution here, is going to end up slightly acidic. Okay, which means that our solution will be a weak acid solution. Okay, so the best type of indicator to use there would probably be the methyl orange, maybe thymol blue, but see how there's a huge range here for thymol blue in the neutral, and then you could use it again for bases. So the best one to use would probably be the methyl orange. Okay, and I think that's it, ladies and gentlemen. So when you come to class tomorrow, I'm going to show you how to do the titration. I'm going to show you where all of your supplies are, and you guys are going to get started on this lab, and it's going to be great. Just make sure you have lots of patience. Okay, I'll see you then.